Which one?
Kelly's thinking of number.
What? Oh, yeah, well, buckets would be how many pebbles? How many pebbles? Yeah, yeah. Yeah. Yeah, it's just let it be phrased in a different way because they will all you can okay?
I just looked at it, you know,
How would your students do on F? How would your students do on F? Which one? F. How would your kids do on F, right? Problems will get a little hard. Yeah, sure.
What operation? No, not
E. C. A bucket and 3 pebbles
So plus.
is equivalent to 3 pebbles. Okay? Okay? Okay. Okay, so this is a snapshot of some things to come. And you know, we've talked a little bit about our population of students or kids that have struggled with math for several years. Their struggles probably did not just start in 9th grade, right? So chapter 2 is a lot more about, again, kind of patterns and rules and tables, okay? Where it's shifting into is in chunk 3, they're going to be doing tons of work with equations. But there's also some middle ground here, right? So can we look at these as equations? How would your students do on these problems? They might require a little more introduction, right? I think there was an important question about if I see things next to each other, do I have to feel like that's multiplying? And what we're saying is the model that we're using is a little bit more around a balance beam or something balancing, right? Okay. So how would your kids do on some problems like this? Would they kind of find it fun? Would they be stuck? Would they find it to be an interesting little puzzle? Okay. G. Okay. G is if a purple hexagon plus 4 is 50. Right? What was the purple hexagon? Right. Okay. So would you? Or I mean that's a good point. And do you what do you want to be a strategy for G? It could be about opposite operations, or it could be that on a number line it's like, okay, here's a 50. You were at something and you added 4 to get there. So where were you? Right? That could be another idea. But again, the number's getting bigger. What do we want them doing? Okay? What plus 4 would give you 50? Some kids might have a sense of something to say on that, and others might not. Right? Other comments on these? Other comments on how you'd work through these, or how they would work? What about, which one was somebody asking about? C. What is C about? Is there anything in the pail?
So
Yeah.
it's not existent.
you're right, there's a little catch here. It's like a pail that is lighter than a feather. That's the weight of the pail, right? So is it non-existent, but it's non-existent, or they could say it has the weight of 0. Either way.
It's very close to 0.
Very close to 0. That could be, right? It's any amount of pebble that you draw would be drawing too much. Okay? It is right. It could be intended to be, yeah, it would be intended to be 0. Star minus 5 equals 6. Okay, how are they going to tackle through that one? Is that going to be something they're going to... Okay? Is that one where you want to go to a number line? Something, take away 5. Or do you want to work with some kind of, with pennies on the table? What would you need so that if you took away 5, you'd be at 6?
I mean, I think one of the things that I always find, this is not dissimilar to children who read below grade level, making sure that their text is of low readability, high interest. So I think some things like this, some kids may be a little insulted.
Yeah. They might.
You know, I mean, I'm just saying they've been through 12 years of schooling and they're going star minus 5 is 6. I mean, I'm just saying, so I'm saying some kids would go, what are you kidding me? So that's what I would look at. I think it's good to reinforce the concept of the variable, and we don't know what the number is, or the number varies, and we need to represent it and things like that. But to actually do a calculation, I would make sure I know who my kids are and what I'm doing. Because,
Okay, Francis?
I think after going through B, C, D, and E, they would appreciate F, G, and H. Because at least I feel confident there. So F, G, and H gives me a sense of confidence versus B, C, D, and E. I'm like, it could be this or it could be this, depending on what operation you're telling me I'm using.
So Francis, I think the point about mixing problems might be a relevant piece, right? And I think you're raising an important issue here. Okay, but again, part of what's interesting here for them to see is, you know what? I might draw the 7-foot pole. I don't just figure it out in my head. And let them know that, right? Because in a similar way, do they think that anybody who's good at math doesn't do making it physical? Do they think that, right? And let them realize that that's not true. So I think it's a genuine issue.
well, I mean, I'm speaking to how they feel already. They haven't been successful in math for a long time, thus why they're in this class. So there's a heightened, I'm not saying, there's a heightened sensitivity on their part. So that's what I look at.
Okay.
I have to agree with Francis
Yes.
that the bottom, the F, G, and H are, I think, like you said, maybe more insulting. But when you think about the B through E, to me, really begins to smack of like coding. I remember coding in college when you're coding stuff and it looks like that. So that to me is actually pretty high level. Our kids may not know it because they haven't been exposed to coding, but it looks like that, you know?
Okay, yeah.
I had 3 different type of students, and some of them has no idea about math. When they see plus sign, minus sign, they're great. So for F, G, and H, very scary for them. But
Scary,
B,
okay.
D, and I, they can use common sense to figure out what it's gonna be.
Okay. So we've got some different populations out here, right? It's interesting, right? Okay, so what I'd like you to do is I'd like you to think of a number. Okay? I don't want you to watch this. Okay? Okay, I'd like you to think of a number. Did you think of a number? Okay, now I'd like you to multiply the number by 5. Okay, now I'd like you to add 2. Okay, now I'd like you to double it. Okay, now I'd like you to subtract 4. How did you know that?
I went your mind.
You read my mind?
To get back to
Okay, now I'd like you to divide by 10. What'd you get?
the same number.
Okay. So here's another, okay, so this is something you're gonna end up facing in chunk 2 and 3. Think of a number. Multiply it by 5. Add 2. Double it. Take away 4. Divide by 10. Now what's the algebra for this, right? The important thing is that there is an algebra for this, right? And it's a fun piece for kids to capture, right? So, okay, 5, what would the next one be? 5x plus 2. I doubled it, so 2, 5x plus 2. I subtracted 4, so then I'm kind of left with 10x, and then I divided by 10, and I'm back at my starting number, okay? There might be some better examples. You know, a lot of people, you can just do this and kind of remember what you're doing also, and then you can try to amaze and make people think you're psychic and whatever. Well, the kids will get walked through, again, the purpose being letting them write the algebraic expressions, okay? So if you really want to know how to do this magic, you just want to go home and start reading chunk 2, and we'll look forward to having you, maybe do some magic tricks for us when you come back in November. Okay? So what we have now is you have surveys and we have an evaluation. Okay? Evaluation. Okay.
Sure. Well, ask you a question before you leave, okay?
Okay, so
Thank you.
take a minute.